Hey, hello, everyone. Welcome to another dotnet AI Community Standup. My name is Bruno. I'm here today with Beth and Alexandre to talk about the AI Dev Gallery. And I know I am the worst host ever, but this night I have a big post in front of me that introduce yourself because I always forget. And I'm super excited about the topic and I jump to the topic. So my name is Bruno. I'm part of the cloudadvocate.net team, live in Canada, not Canadian, notice the accents and yada, yada, yada. You know the story there. Super happy. I see a couple of comments here from Romania, from India. Thanks for everybody who is joining. But now I will invite to Beth and Alexander to introduce yourself. And hey, I like your nickname, Beth, there. Do you want to introduce yourself or Alexander?
Sure. I can start. My name is Beth. I'm on the Windows Developer Platform team. Our overall goal is to try to get more people to love Windows and build on and for Windows. I'm here actually in place for Nicola, so that's why I'm AKA Nicola. This is Nicola's one of the founding members of this project, so I want to bring his name into this somehow. He's a little busy at the moment, so.
Yeah, and I'm Alex. I work on the same team as Beth, and I work on the AI Dev Gallery very closely with the .NET team. And we want to talk a little bit about what it is.
Yes, and hey, full disclosure here. I think it was Luis who mentioned that we can talk about this a couple of weeks ago. I cloned the repo because we are going to share right now. We are going to show a couple of things. I pressed 5. I was super started when I play around it, but that was 2 weeks ago, and I didn't even come back to this. I didn't have time. We have Ignite, and we have AI Tour here in Toronto who finished yesterday. So I'm also in learning mode here to ask questions. And hey, if you have questions or more, I am watching the chat right now. You're going to see me watching here, and there are the chats. So we are going to try to answer the question live or have it in the queue to see what we have. And again, thanks to everyone from UAE, Scotland, Virginia, Astana, Turkey, Bangladesh, Panama, a lot of people here and there. So, hey, super happy to be here. And hey, should we start? Alexander, do you want to share your screen or do you want to tell a story how we get here? What do we have?
Yeah, absolutely. I can most definitely share my screen. Then share screen.
And in the meantime, James mentioned here that .NET is multicultural. I will say yes. I support a lot of LATAM activities and events. And hey, it's super nice to see people from all around the globe using .NET to do all types of applications. And this is one. So hey, I have your screen ready. Let me share it and put it here. There it is.
All right. So this is the AI Dev Gallery. It's an application built fully with .NET. And it is an application built specifically for Windows developers that want to understand how to embed AI into their own Windows applications, right? So we leverage the Onyx runtime NuGet packages and also .NET and a bunch of .NET specific packages to provide samples on how to do specific things, specific AI things. So if I just maximize this, you can see a bunch of different samples that we have. We have samples that help you write code on how to generate text using AI, or to do RAG, retrieval augmented generation, text summarization, detect human pose, and a bunch of other things, right? So in this case, I'm just going to the samples tab here, and you can see that we have our samples categorized and grouped by different types of models, right? And different things that you can do. So I'm just going to maximize them all here, just be a little bit easier. But on audio and video, you can see that we have like transcribed audio and video. In this case, we're using Whisper. You can select different models. You can download the models from here. And this is an application that is very attached to Hugging Face and GitHub. So all the models that we're using here, they're downloaded from Hugging Face, directly from Hugging Face, and you can embed them in your applications. But we're leveraging the Onyx runtime to load these models and do the inferencing on specific hardware that you have. So .NET helps us with that for the CPU part of it, and some of the tensor operations are also built using the new tensors library that we have on .NET. But we're also using all the new abstractions that are exposed by .NET. Let that be the iChat client, which I do have it here. Yeah, We have a specific Gen AI model for chat clients. And the interesting thing here is that it's super, super easy for you to replace within the exported projects. That's something that I'm going to show later on. But the idea is that you can export these projects outside of the gallery. You can click on this button here and export a Visual Studio project, and you can use these samples in your applications, just copy the code without having to actually look at all the single files. You could do that. You can just click on the tab code and see all the files that are related to that specific sample, but you don't have to. You can just export that, right? But back to the chat client interface.
Sorry, Alexandre, one question. And two, really. Can you zoom a little to have at least 30
Oh,
lines?
absolutely.
So
Absolutely.
and
Alex
the second one? Yeah,
Alex
sorry,
is
Beth,
what we
please.
call 10 times engineer who would love to show code all day, every day. I would just stay in the UI for, like, if it was me, I'd be like, here's a tab that does this.
Let's do that, Beth. So you tell me where to click, and we can show the app first, and then we go to code.
No, and also before moving forward, I just shared the link also in the comments of the repo. So if you want to access this, that's a repo. It's on the Microsoft main organization. So GitHub, it's somewhere here. GitHub.com/Microsoft/AI Dev Gallery. So hey, everything that we are going to show, you can also go and get deep there in everything. But no, I just want to tell people that if you check the comments, the repo is also there and it's part of the resources of the session. So hey, sorry, Alexander, it was just
No, absolutely.
And
Beth is right. I always try to jump to code, but it makes sense to actually show what the app can do, right? So if we go to tags and generate tags, and we actually load a model that's slightly faster instead of running on the CPU, I'm going to load 5390 DML that is actually running on my GPU. I have quite a beefy GPU here, an NVIDIA GPU. So if I say, what is .NET? This is going to load the model, and this is running fully local on my machine. This is not attached to any subscription, anything on the cloud. I could be completely offline. This is running the models locally. It's loading the model on my GPU, and I can actually look at that. If I open Task Manager, go to the Performance tab, I can actually show you.
There's a little bump.
GPU.
you have the GPU pump. Oh, cool.
Quite a large GPU bump. So if I click on generate again and swap, you see the GPU bumping. Yeah, the usage right here, bumping and using a lot of my resources, right? And then it goes down, of course. And this model is actually loaded on the GPU. So you do need memory on the GPU to actually be able to do that. But we do have samples that also run on the NPU if you are on an ARM64 device, right? So on ARM64, and of course, on some Intel devices, newer Intel Copilot Plus PCs, we have NPU, so neural processing units, and we have some samples that actually run on the NPU, and they even offload the workload from your GPU into the NPU. So let's say that you're doing some kind of image processing, actually running some models, and you're also doing some GPU processing, let's say some 3D gaming running. You could run all that code on the NPU, offloading that GPU to just do what a GPU is supposed to do, not running models, right? But of course, we have all the code here. You can literally see how do you make calls to that. You have the Gen AI model that, again, as I mentioned, it calls the iChat client interface, but the .NET exposes specific implementations of this interface that are based on Azure, right? So you could simply swap that interface, an implementation of that interface that is the Azure implementation of it. But all the code that we have is based on the iChat client interface, right? So all this sample, and again, for all of the Gen AI samples, all of the text generation samples that we have, all this code would literally just work as is. We wouldn't have to change a single line of code to make that work. Just instead of calling and setting, where is it here? The get iChat client async internally would just return a different instance of a different implementation of that interface, and the code would just work, right? But instead, it would run on the cloud.
Sorry. So there is a question that we also get a lot when we do other sessions and more about NPU, because NPU are kind of, I will say, new. Not everybody has a new laptop. I have a big gaming machine here with a big GPU for a lot of stuff, but still don't have an NPU. And we also have questions about how easy it is to switch from CPU to GPU and now to NPU. So is there a specific library that we use in the Onyx when you use Onyx to do NPU, that will automatically detect? Do we have, because you mentioned NPU here, do we have something there? Like an example, Red is asking how the offload works. It automatically go for NPU if you have one, or you need to specify that go for NPU?
You have to specify that. We don't have anything that automatically detects, oh, you have an NPU, or let's say you are online, because it really depends on the scenario that you're trying to achieve. These models are not exactly the same. Not exactly, I mean they're completely different. If you just try to run Phi3 Mini DML, like the Phi3 Mini model, it is not going to be as capable as the Azure OpenAI models, right? That you have. The O4 Mini, they are extremely larger models that are running on dedicated hardware, running on the cloud, with tons of GPUs on the cloud to do that processing for you, right? I'm running this on one single GPU on my beefy desktop here, but if you try to run this on a lower end device, you're gonna see the tokens being streamed one by one. It's gonna be slow, right? So you really need to understand the scenario that you have and you're trying to achieve to understand which models make sense for the specific moment in time, right? So let's say that this running locally could be a fallback if you don't have connectivity, right? You don't want to completely disable a functionality. You want to run that functionality if you don't have the hardware running locally. Or you could do the other way around. If you have a beefy machine, you're always running that model locally to save resources from you, the developer, right? But if you're running on a lower end device that doesn't have the hardware that will do a minimum performance of that model on that specific hardware, then you offload to the cloud, right? It's really up to you. It's really up to your specific needs. Some of these models will run on literally any hardware. Like if you try to run the Whisper models, they are very, very light. Not Whisper Medium. Whisper Medium is slightly larger, 1.3 gigabytes that you need to load on the GPU. But if you load Whisper Tiny, 73 megabytes, right? That's a very, very small model that will do audio to text. So you can literally use this to say something and it will translate that to text on multiple different languages, right? So it's just one other thing that you could do locally, always do locally. There's no need to go to the cloud specifically for that task.
I think it might be a good time to talk about the benefits and the design decisions behind local AI, so that we understand, like why we built this gallery and why should our developers care about local AI as well. So there, in the revolution of how AI has been working for the last, decades or so, there has always been like the model is evolving from the simple things that it can do to today what large language models can answer and help you do things. And there's also revolutions on how our computing powers has been changing. So we've evolved from doing device management on the CPU and then gaming graphics specifically on GPU, and now today NPU really is doing a better job. Like think of it as doing a better job of AI workloads specifically, right? So now that we have this capability of running things for AI specific workloads, then we're deciding on how do we have all the chips that do the best job that they can do. And then running this local AI models have a certain appeal to our customers when you think about it, especially in the finance industry or the healthcare industry, when data security and privacy is a big concern, right? So people want to, so that's like something that we always tell our developer friends, like if you're building in these industries that has these concerns, maybe local AI is the solution that you're looking for in your application development. And then there's other things like, how do we make this local and cloud connected? Like when I don't have the internet access or low latency situations, like how do we better utilize the devices that's in everybody's pocket on their desktop to do this work a little better. So that's the whole idea behind bringing more local AI into, everybody's life and surface. I guess a lot of these NPU machines would be able to enable us to do.
Yes, and hey, I didn't even know that we have a tiny version of Whisper. Okay, this is
Yeah.
recorded, so I will probably not supposed to say this. I tried Whisper with Python some time ago when it make it public, when OpenAI make it public and re-release it. I tried a library with Python. I like it. It was fast, it was cheap, but I didn't even know that we also have a tiny version that is literally 70 megabytes running on the CPU and more. I will take a look at that. And just to recap a little, because I really, really appreciate that you explained everything here. Each model is different. So we have a model for CPU, we have a model for GPU, we have a model for NPU. So you need to download that different model. The libraries are different. And the scenario, as you mentioned, Alexander, is what we need to do. So, hey, I really, really like that we have the options here. And this is more kind of I don't want to see a playground, but see as a super cool sample library where you have tons of things to do and learn. And hey, I will try this and I will try that and more and more. And I love it. We have some questions before moving forward. I know that we have some moving forward, but as usual, we have people going for light mode and dark mode and talking about that. I'm happy in light mode. I know that in 2024, I see that you also have light here, Alexander. We are kind of the weird people who still do light, but yes, I will say personal preference, and doesn't affect the gallery. You can switch to dark if you want or whatever.
No, I use both. I use light at work during the day, and I use dark on my laptop when I'm working from home on a different setting.
Okay, hey, that's cool. Nice to know. I know that is a personal preference. I use a lot of time. I use dark when I'm working and I need some kind of deep focus on what I am doing. And for streaming, I usually switch to light because somehow in my head it's easier to read. But I also have people who said, no, I read better when it's dark. So
I don't know how to code in night mode at all. Like, I have never done it until this last event that I went to in the Netherlands. And we were doing live coding in our session, and he said it's a lot easier for people to read light mode, so we have to like switch it. While we were doing this, you can tell that I'm like looking at the screen. I was like, where is this line that I was looking for? There's literally like comments right above it. But yeah, Alex is one of the unique ones.
Yes. So, hey, sorry about that. And again, I know that when you're presenting live and you have a projector and these kind of things, usually light is better because of the reflection and the light in a room, but depends on the scenario. There are no, I think it's a personal preference here. And hey, sorry, I interrupt the flow, but I want to clarify, get the kudos or more about the tiny whisper that I'm going to give it a try. And yes, you can move. We have a couple of, or I don't know, if you want to take a look at the question, there are a couple of questions here.
Yeah.
Like Jose is asking, let me bring Jose, if we have any vision transformer scenarios in the AI Dev Gallery.
We have a lot of image-related models, right? So we do have PhiVision and PhiVision for describing what an image is and doing something with an image, or Stable Diffusion to generate an image. This machine is brand new, so I didn't download that model. I haven't set it up yet. We do have image classification models, such as MobileNet, ResNet, and SqueezeNet. Yes, and those are SqueezeNet is 4.7 megabytes, right? So we have some models that are very, very tiny. And even being that tiny, you can run them on a GPU. They do have their minimum requirements. You have to look it up. It's not that straightforward. You have to be a little bit careful with what they do. But if you actually if you click on View Model Card, you can look at all of the definitions of what they do, the specific Onyx versions that they require, and all the definitions. And these are literally coming straight out of Hugging Face or GitHub, depending on where these models are hosted. But yeah, we do have a lot of image models, right? What else? We have segment image, which is actually quite cool. And I don't have that downloaded here. These are actually quite small. I can just download it now. So detect human toes. That's actually super. Oh, I do have that one downloaded. There we go. So it gets an image and returns a an array of, I think, 14 points that are related to the human skeleton, right? And this is actually one of the models that runs super, super fast. I think their inference is 6 milliseconds that they have on some specific hardware on their model definition, on their description. Yeah, they have like the inference here. And you can look at all the different parameters and how they work. It's super straightforward for this particular model. Sometimes you do have to do some pre-processing and post-processing, but all these samples that we have, they have all that code for you, right? So if you want to load the model and detect the pose, this is the pre-processing that you have to do. Load the bitmap, you resize the image to what the model is actually expecting to get. Then you create the tensors that you're actually sending to the model. You pre-process them with some standard deviation. I have no idea what that is. I don't have to know. We have some helper functions that actually do that work for you. And then when you actually get the list of all the key points, the coordinates that are returned by the model, then you can actually draw. We also have some helper functions here to render the predictions on top of the image and draw that on the screen, right? So it's really up to you. You could easily get this model and put it on top of an image feed instead of just a static image and have like a hand wavy thing. This model actually do run as is, exactly the same model runs on the NPU on Qualcomm devices.
As a former Kinect developer, I was super happy / not happy at all when I started to see this post model, the HR and others, because if you are all like me and you know the Kinect device that used to detect bodies and you can play with the Xbox and more, when we have the SDK, you can basically do this, and it was a huge advance for a lot of things. But then you don't need the Kinect device anymore. The Kinect used to do this with the camera, then an IR camera. They have different sensors to get this, to basically detect the body, detect your joints, detect your hands, and more. Now you have models that they can do this with a photo, with the 2D photo. And they are also, how big is this one? This is a small one, yes?
This is small. This is 100 megs, I think. Yeah, 108.
Yes,
109 megabytes.
In the context of model. Yes, small in the context of the small language model. And it's amazing. I'm still, as I said, I'm not happy as a Kinect developer, but I'm super happy that we can do this literally locally right now with a small model that can run all of this. And I will probably add into the list to try to do something live, to try to do a camera detection scenario where you can do something like this and you have live this, running this, and just give me the base code to run it there locally with Onyx more. I love it. Sorry, Beth, I think you were going to say something?
Oh, I was trying to say we taught this exact sample at Ignite not long ago, and we were trying to say, like, if you have these videos of someone doing like sports related activities, you can do like things like sports prevention in like golfing or like, I don't know, American football, like by defining these key points of how the players are moving. So there's a lot of application values out of these image models as well. I also there's also one thing I just remember that I want to point out. There's like all these NuGet package highlights at the bottom right corner. So like every sample that you're looking at, you would see directly there like what kind of NuGet packages that you need to include in order to make these things happen. So I think that's a cool little thing over there.
Yeah, and again, this project is completely open source. So if you click on the contribute button here, it opens up our GitHub where you can literally send pull requests, open issues. We do have a few issues, of course. We were trying to work them out and get ready with a more stable application that we can share with you. But yeah, it's completely open source. Please share, please send pull requests. We would more than willing accept a pull request that adds image video detection on this sample, right?
Yes, and I will say also in terms of the community part that if you have an idea and you're seeing that you can put all of the pieces and you're seeing that you can put some pieces together to move forward with the idea, the scenario, and more, hey, and you can make it go into the issue. There is always a community people ready to help there. And hey, keeping an eye of this also help us to know what is the community needing. So I will make this up. But if nobody cares about voice to text model like Whisper, which is not true because there is a huge market there, we will probably, okay, let's move the focus and do more vision models or something like this. So please share your feedback. There was someone asking here, sorry about this, about if we are going, if we record the session. Yes, sorry, we didn't, I probably didn't mention at the beginning. This go in my big post-it. Everything is recorded. You can watch it live now, or you can watch it later. But yes, and the repo is part of the repo, and the samples are part of the contents on the video, so you can go there. So, hey, this is super cool. And I didn't even know that we have a post one and we can do with extensions, AI, everything local, and which is very small that we can run this. And hey, I love it. And we have a couple of people asking, saying thanks. I will say this is a thank, and we love the content comment, and I really appreciate that. But I have one here, market that, and someone here asking if we are starting to develop an image classification model for a particular things, what we can do. I have an answer here, which is you can probably take a look at machinelearning.net, which is an amazing SDK extension framework. I really don't know how to qualify this, but they can give you a set of libraries where you can use. And I think they internally use the HRNet or SqueezeNet to basically create your own image classification model or object detection. So you can take a look there. But do we have something for, oh, sorry, I hide the question. Do we have something here to retrain, do kind of a, I don't know, fine-tuning of a model or more to do image classification, or it's not part of these samples?
So the gallery is for doing the inferencing of models. It's not for fine-tuning models or training models at all. We do have another solution within VS Code within the Beth, what's the name of that product again?
AI Toolkit extension in Visual
AI
Studio.
Toolkit, yes.
Oh, yes, the AI Toolkit.
And that's the solution that we have for training models.
So there are two ways to think about this, right? If you're familiar with Olive as part of the Onyx's project, you can, like, if you prefer to use more of a command line, I know what I'm doing with Python, then Olive is a great place to, take a look at the model fine-tuning and also optimizing for hardware. For example, in our situation, we've taken the Whisper example from the Olive side and fine-tuned it to do a lot of different things. Maybe not specifically for this, but like for our demos. So we've definitely gone through that process. And then if you are more familiar with, I want to use an UI to give it the parameters, top P, top K, all that stuff, and fine-tune the model based on what I have. And then you can use the AI Toolkit in Visual Studio Code extensions. It's more like like a UI representation around Olive. Does similar things. I think it's more, Olive is also designed more towards optimizing the Onyx models. Yeah. So if you want to do other things, there's other solutions out there, open source or not, as well. So.
Yes, and hey, just take a look also if you want to do something. I don't want to say simpler, but you can start very fast using ml.net because it's literally 10 lines of code and you have your set of initial database, your labeled images or whatever you want to use it, and you can retrain your model. And it works very, 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 very good. And you can run, by the way, you can run it locally. As far as I remember, it's been a while since I used ml.net, but you can even connect your Azure subscription and run it on the cloud, which is also going to help you a lot if you have images and more. Because in example, I haven't used this one, but I remember when I tried to use my first stable diffusion, whatever, locally to generate an image, even if I have a house powerful GPU, it took a while. So there will be scenarios that I you just show it fast. I can't remember which is the model that we have, but image generation, just be aware that usually requires a lot of power on your side.
Yeah, the image generation model, we only have Stable Diffusion 1.4. It runs both on the CPU and the GPU, and it does take a few seconds to generate an image. And by a few seconds, I mean around 30 seconds, 20-something seconds in my beefy GPU, right? So it is not light at all. So whenever you're generating an image on any of these AI agents that we have out there, Windows Copilot or ChatGPT, just be aware you're actually consuming a lot of energy.
Yes, and that's another important one. We have one of the demos that we share usually is analyzing images from a traffic camera, and we use You have a scenario where you can use Llama 3.2 vision or Phi 3.5 vision. And just to give you a sense, the difference, very small images to get an analysis, unit running on the GPU and a home GPU took between 1 or 2 seconds. Run on CPU is between 5 to 8 minutes. So if you want to try the generate image on the CPU, okay, have a coffee or a tea or water or your preferred drink nearby because you are going to wait some time.
And I think that's the reason why we're starting to talk about NPU as this whole dream of that we can load the AI workloads over there so that graphics can do their own, like the GPU can do their own things. But that road is still developing. All of these models are still there's still room for improvement for us to bring the models that supports different NPUs, especially with all of the providers that's coming up with more and more improvements on their NPUs as well.
Yeah. So I literally just clicked on a button to download the FFNAT 54. Actually, let me download the other one so you guys can see it again. So I'm downloading this model with literally just a couple of clicks. And with this, I can run it on the GPU, and it does the processing of the image. The time that it took, I don't know if you noticed, it took a few seconds to actually start doing the processing. That was actually loading the model in memory. But once the image was actually provided, it inferenced quite quickly. So we don't have any timers on the system. I think we might have a few debug write lines on timings, but they are super quick. So you could most definitely run these models on an image feed and do that live while driving in a car. I do not recommend it to try to build anything like that because it's going to be a lot of work.
Yes, and hey, a fun one here, sorry, is that there was a question here around Red, when you move to local to the AI, how do I keep the cost low and more? I will share the personal experience there. So, in example, using a Phi 3 or Phi 3.5 locally. You can use it locally. You can learn, you can test, you can do some prompt life cycle where you improve your prompts and more. But then at some moment, if you go to production, you probably want to sync to move to the cloud. Why? Because in the cloud, you have, even if you have cost, you have other benefits. Like an example, in Azure AI Foundry, you have content filter, which is going to be a very similar model, literally Phi 3.5, but at the beginning and at the end, you are going to have a filter that's going to avoid jailbreaks and more. So there is a whole story, not to talk about today, between why cloud and why local. Beth mentioned something at the beginning. Well, if you want to, in example, keep your data in your network, or you don't want to avoid with loss of connection and more, you want to have A or B or C. But at the same time, the cloud has a lot of benefits. It's not the objective of this talk, but you can keep low cost there, but also when you move to the cloud, you have a lot of extra features, I will say, that otherwise you need to implement it locally. But again, it's a whole conversation, and we probably want to. If someone wants, we can host a session just talking about A's, B's, or C's, because they were probably going to be a hybrid scenario where you do something local, then go to the cloud and local again, or something like this. But hey,
I think the goal just like the goal of .NET in this case is just to make it simpler for you to switch between each solution, right? We're not trying to decide for you. Like if you want to run your model on the cloud or if you want to run it locally, .NET is there to support you. We have the specific interfaces, and you should not need to change all your code to run something on one specific hardware or another. .NET is literally just this abstraction layer that is making it easier for you. And all of these libraries like the Onyx runtime.
Yes, and that's a super important part in how you do this. Hey, there is a question here, and I need to give both of you some story there. In the last session, we were talking about, I can't remember what topic we were talking, but we started to talk about transformers and how they work. And I share, one of our colleagues shared what I really like is a 15 or 20-minute video where someone built literally a GPT-2 in Excel. And it guides you what it's doing, how it's working. It basically built a deep network, a neural network in Excel. And I think it was a fun experience, but it's also very informative in order to see, okay, this is how transformers work. This is not for everyone. You need to have some knowledge about machine learning, deep learning, and more. But if you have a basic knowledge, I will say this is, for me, it was a good one. And we have Jose here asking the question that, hey, you have any tip if someone, besides using the model and have a tool like the AI Dev Gallery, can also learn about transformer, or do you have any tips there to learn a little what's happening behind these models?
I'm going to
Beth?
defer this to Alex.
Yeah, this is a hard one. We have a lot of content out there, and I would literally just go for the content. I don't think there's a super bullet on how to learn these things. I myself still am not an expert, even though I've helped build this app and I helped build a bunch of these samples. Like, it is not the same thing as actually training and building a model or understanding how transformers works. They are different skills.
Perfect. Yes, and hey, it's literally, as I said, it's depend on what you want to go or how you want to learn. But I'm more on the side of consuming models that creating. But at the same time, it's kind of nice when you can learn about what is working, what is happening there. Let me go back. Sorry. Anything else? There are a couple of other questions here, but
Let's go on with the questions then.
yeah. So we have Jose again here. It's always, I appreciate Jose's here asking questions and more, saying that, hey, we use DirectML. We need to have a specific GPU, NVIDIA, AMD, Intel, or anything, and say thank you. No, thanks to you. We appreciate the community question. We are here to help. Do we have any feedback for this one?
Yes. So we do have some DML models as part of the gallery because they're available in either the Qualcomm AI like Model Hub or somewhere on Hugging Face. The idea behind DML is exactly what you were talking about, is trying to abstract that layer of differences of execution providers from different chips onto a unified, like we want developers to not worry about like how to reach those different GPUs. But so as we are evolving our technologies and how DML is working with different chips. So like I said, this is all very young, I think, conversations that we can have on AI. So I think there's definitely evaluations on how do we work with different chips a little bit better going forward as well. So stay tuned on that one as well.
Yeah, within the gallery, whenever you see GPU, that means DML, right? So right now, that's what it means. But so you can even see here, Microsoft.ml.onyx.runtime.dml. So it is the specific compilation of Onyx Runtime built for DML, right? For NPUs, that's going to be slightly different. We are approaching it with specific execution providers for different NPU vendors.
Bruno, you're muted.
Yeah.
Hey, I haven't had a lot of meetings this week because I was live doing things. This is my first "You are muted, Bruno" in the week on a Wednesday. Kind of a record for me. No, I was sharing the link of the AI toolkit. Thanks for sharing this in the comments. I was copying and pasting about that, catching up with the comments and more. So yes, and hey, I was expecting the question. We talk about Windows. And how about the other OS, Mac? They talk about Mac here or more. I'm guessing that today we have this, but do we have any plan in the future to do other operating systems? If the community asks, or we can open. By the way, once again, this is open source. If someone wants to do a first draft to run this using Maui, or someone mentioned here Avalonia, or one of the tons of stuff that we have to do multi-platform, let's go for it. But in our size, do we know if you have a plan for this, for other platforms?
Our team specifically is trying to help more of our Windows developers. This one is built on WinUI and WinApp SDK, so that alone wouldn't work cross-platform, but we do love that we have different solutions for our cross-platform developers, such as what you said, .NET MAUI, or, if you're interested in the web side of the things, there's also things like React Native and PWAs. So I think there's a little bit more investigation that needs to do. We have people working to look at how WebNN works across different platforms and uses and on the Windows platform specifically how that works. So I think more is going to come soon. There's no concrete roadmap or plans at the moment, but these are great discussions. We would absolutely encourage you to start on our GitHub repo. So we just opened up our discussion board, and we would love to have these conversations with everyone who's interested.
Yeah, in terms of the code itself, we do have some ties in and dependencies on Windows-specific things, like the app itself, as Beth said, is a WinUI 3 and WinApp SDK application. But it doesn't mean that if you export the project and try to copy 95% of the code, it's just not going to work on Mac or Linux, right? Specifically because the Onyx runtime does support Android, iOS, and Linux, as far as I'm concerned. Some things are just not going to work. Like the DML part of it, it is specific to the DML, which is a Windows-specific thing. It is just not going to run anywhere else. But the code itself and anything that uses the Tensors APIs from .NET, this is just going to work on other platforms. So yeah, feel free to export this project and try to build it and replace the image classes that we're using with more generic image classes from other platforms or from .NET, and it's very likely that things are going to run. The performance might differ, and I make no promises here, but it's very likely that some parts of the gallery, if you just export something and replace some things, it is going to work.
I would love to know if you make that happen. Like, let us know how you did it and share your project, I guess.
Yes, and hey, and I think that we miss a little part here, but we talk a lot about Onyx, and I don't know if a lot of people know what is Onyx, because you just mentioned that this is kind of a mix, but Onyx plus DirectML for Windows, but I can do it, but you are the expert here, and you are going to give a much better answer trying to explain Onyx. By the way, my explanations are usually like a 5-year-old people talking about ABC. Do you want to give a little context about what is Onyx and why we are using Onyx? I know why, but just to explain what is Onyx here.
Beth?
I'll have Alex answer that.
Sure. I can do it. I mean,
talk about it.
Part of what we have, and I can go if you want for this, and please build on top of this. So Onyx, I think the main website is onyx.ai. It's kind of a standard to describe models, and again, this is a very simple explanation. There it is, explanation, and behind Onyx, you can see a lot of super popular names. And the last time I was here, I think I saw everyone: Microsoft, Amazon, Nvidia, everyone but Google, but they are probably already here. So it's a super cool because it's kind of a standard that when you have a machine learning model that you train, an example with TensorFlow, you can export it to Onyx, to a platform, and it's going to be available to use in that platform. On the .NET side, the cool part is we have libraries to work with Onyx that help us. When you have that model exported in Onyx format, you can basically load that model, in access to the model locally, and start to use it. And as Alexandre mentioned, there are different libraries, but you can literally do the same code to run on Windows, Linux, Android, and more. And this is something which is super cool because it literally is an abstraction on top of a model. Otherwise, if you're using TensorFlow, you need to use TensorFlow or PyTorch or whatever. So, hey, I'm a big fan of Onyx. At the same time, going back to what you mentioned, I know that probably the implementation and what we use to open the model, whatever, in Windows will require some tweaks or the different library, at least in Linux, making this up. Because I remember when I was doing something with Phi and I tried to run the same with Onyx on a code space, which is a Linux container on the cloud that we can use in GitHub, I need to tweak a little, the library at least. So, hey, that's Onyx, and that's why I think it's super important, because once you know Onyx, and I would say no Onyx in quoting, it's super easy to start to download these models and do more. And if you want to know about this, go for Hugging Face. search for the models that support Onyx, and probably in 2 clicks later, you are going to be able to try at least access and reuse something of the model. Does it make sense? Did I miss something?
Yes.
Yeah,
Yes, that's super helpful.
I think for us specifically, there are 3 concepts, right? One is, what does Onyx mean? Which Onyx is the open interval like format for ML and DNN models. So Onyx alone is a model format. We use those models in our gallery. 2 is what's Onyx runtime. So think of Onyx runtime as a black box, which takes in Onyx models and input data and then give you some output results. So that's what Onyx runtime does. And within that black box, there's things like graph partitioner, there's DML as part of it as like a graph optimization and execution or executors. And there's also hardware accelerators for, GPU, NPU, whatever. There's like a couple layers in that box, right? And you can definitely read more in, like Bruno was saying, in the Onyx runtimes docs side. And the 3rd layer for us in the gallery, or for like how we teach people to do these things, is the ORT generate APIs. So if you are specifically working with generative AI and you want to use these like API layer that's available for you to just simplify your development process, I think that's the NuGet package that you're going to want to include as the ORT Gen AI package, like I think I check client, all these things that Alex was talking about early on. But there are many ways to build these solutions. Like someone earlier was asking, Windows is only one way. Python is definitely very popular. There's so many different ways to utilize Onyx runtime, and we love our partners from the runtime team as well. So shout out to them for building all these amazing APIs and tools to help developers be more successful.
Cool. Hey, Jose is asking if we use Tor Sharp under the hood. I will say no, but keep me honest, Alexander, Beth.
Yeah, we don't. We use the Onyx runtime.
We also everything is Onyx, so the base core of everything is Onyx. Okay, perfect.
Yeah.
I was guessing that is a no, but just in case. So let me go back here. Let's clean the Mac OS. Hey, we have another question from the beginning, which we just answered this when we said talk about the platform more, but are we planning to support Coral TPU cards? I'm guessing that because we are on Windows mostly, and I never heard that we are running TPUs on Windows. I may miss something. I don't know. It rings a bell that we have TPUs on Windows.
I'm making notes on the side on things I need to research as people asking questions.
Yeah, that's a great question. I don't think we have an Onyx runtime execution provider for Coral. Yeah, I think that's just the gist of the answer. It just we don't have an execution provider for the Onyx runtime that runs for Coral devices. Like I use Coral. I have one at home for detecting. I have a bunch of cameras, and I use it to run a few image detection models to detect, oh, this is a package, this is a bird, this is a person on my camera feeds that I have all running on the Raspberry Pi 5. It's super, super cool. And of course, the models are running on the Coral, not the board, but on the USB one. So it's super, super straightforward. So I do see why you would want to run that. But since we don't have, at least not that I'm aware, an execution provider for Onyx, this code, none of it is going to work on top of Onyx. Yeah.
Yes, and I'm guessing the same because I have something similar using the Intel Vino in a Raspberry Pi. I think it's Intel Vino. It was one of the first one. This is amazing blue stick and more. But yes, I think that now that we have something for Windows, we have an Intel SDK for Windows, but I will guess that there's still not support for Onyx, which is why we don't have it here and more. But I love the question about TPUs because yes, there is a market, there is a community for that, and it's not this one yet. I will say yet because there will always a boring developer that will probably make something amazing during the night, and we will have an ABC running that to test this. So we have some thanks here from James. Hey, James, this is not me. It's the guest and the content. I'm just here doing that jokes. And let me see if I just miss one here. Max, Android, and No, I think we covered all of the questions. I don't know. Do we want to share something? Do you want to share something else? We have 5 more minutes or a little more before the end, or anything else that you have in mind. Once again, thanks, Beth, for coming and replacing Nicola on last minute. But anything else on your side that we have at the end?
I think we covered most of it.
Since this is a .NET event, I do think there's a lot of goodness from .NET 9 and the package that we're using that, like before when you're writing these samples, there's a lot of plumbing work that we have to do as developers, like by ourselves. And with these packages coming out, I think Alex and Nicola actually did a different session at .NET Conf maybe on talking about like how this package is simplifying how you would work with tensors, for example, and other things. So definitely check it out and try out the version that's on Windows, and also try out your own ways with .NET packages and Onyx Runtime and Olive. Even fine-tune your models. I think we have a lot of different tools and frameworks to offer. And the second thing from me is I would absolutely love to hear from everyone your feedback. You have our repo link. I can't stress this enough. Like, that's the only way that we can improve. And we are trying to plan for, the official release soon. So this will help us prioritize what we need to see next, what we need to do next for the foreseeable future. And we, as a team, Alex and I and other people on our team, we always enjoy interact with our communities very much. So that's my 2 things. I'm going to hand the microphone over.
Hey, no problem. And hey, I will say that, yes, we are getting to the end, and invite once again to the people to go to the repo, take a look at the repo for kids, give it a start. We always love start. Give us some feedback here and there. And I want to also, once again, thanks to you both, Beth, because this was super. We have another session where something happened and we are here. And when I saw this, and I missed this one, and I tried to be up or everything, but when I saw this, I would say, yes, I want to talk about this. Yes, we need to talk about this in the .NET AI channel, because this is literally an amazing starter point for people who want to do something here. Even learn about Onyx. I think this is a great way to start to take a look at the code, start to find implementation. And I don't know, I have the feeling that .NET developers, we like to have a reference code. We like to learn, but if we can copy, paste, and start to play around and more, this is something that we like, and this is exactly this. You have everything there ready to go.
Cool.
Yeah.
Perfect. So I don't see any more questions. I want to thank to all of you. See you on the next time in a couple of weeks. Have an amazing December, Beth, Alexander. We are going to keep on touch for sure. And when you have a new version, please let us know. We will love to have you both here again.
Absolutely. Thank you. Thanks so much for having us.
Perfect. Goodbye, everyone.
Bye.